Shita.
Respected resource person of today's webinar, moderator of today's webinar, Dr. Hema ma'am, from Computer Science and Engineering, Scientific Technology and Research Academy, Hyderabad, my dear colleagues Nishant sir, Praveen sir, technical support Dr. Ajay Khushwa sir, all respected faculties from different colleges, and my dear participants. Myself, Assistant Professor Sheetal Bora from the organizing team of today's webinar, Analysis of Algorithm and Bigo Notation, welcome you all. Hope you all are in best of your mood and enjoying a good health. Instead of cursing the darkness, light a candle. Our today's speaker believe in it, and that's why in this COVID pandemic also our speaker is ready for today's webinar. Before starting a webinar, I would like to introduce our speaker of today's program. Challenges are what make life interesting, and overcoming them is what makes life meaningful. He is having many feathers in his success cap, of which I would like to mention here some. He is an eminent educationalist from Vidarbha region. He has been working as head of Department of Computer Science and coordinator of MCA department in Sardar Patel College. He is the chairman of Computer Science Board, Gondwana University, Gadchiroli. He is a double PhD holder in professional subject that includes computer science and management and has written 63 books, and with re-edition this figure goes to 111, which is a very big figure. So far he has been credited with 2 patents, 11 research scholars have been awarded a PhD under his guidance, and 6 MPhil students awarded. He had trained more than thousands of PhD research scholars and faculty members on the topic of ICT and plagiarism. He has worked as a resource person in faculty development programs, refresher programs, PhD coursework, etc. He has been the chairperson and resource person at many national conferences and academic staff college, and presented many papers at national and international journals and conferences. He is a member of many professional bodies that includes CSTA New York, IERDC Hong Kong, ITEC Mumbai, etc. He is also sharing his ideas and expertise on many important committees that includes IQAC, NAC, and research, etc. Most important, to honor his dedication and determination for his work, he has been awarded many awards that includes prestigious awards like Ideal Teacher Award in 2012, Best Writer Award in 2013 by RTMNU, a holder of India Book of Record in 2014, and for writing Maximum Books in Computer Science and recipient of Ideal Teacher Award in 2016 from Gondwana University. He is also awarded Distinguished HOD in 2017 from Computer Society of India, and in 2019 Shikshak Ratna Award has been awarded to him. As a social responsibility, he has donated blood on 11 different occasions and published 54 articles in Hitwad newspaper, mostly on research for making awareness in the field of research. And so far, he has uploaded more than 95 videos on teaching aids for faculty, academic, research, and other utilities on YouTube during this pandemic also. So here I am introducing a dynamic personality, Dr. S.B. Kishore sir, the resource person of today's webinar. Dr. S.B. Kishore sir.
Thank you very much, Madam Shital, Madam. Respected moderator, Hema, Madam, my dear faculties, Nishant sir, Nishant Shashakar sir, Praveen Thakre sir, our technical team expert, Dr. Ajay Kushwa, all the respected teachers, faculty members across the various colleges who have joined on YouTube, all my dear students who have been here and on YouTube. So welcome to one and all, and I'm really glad that actually I thought to make this program for only for the first year student, but later on thought that this subject is open for one and all, and that's why I have thought to make it for the public only, so that one will be able to learn about this particular topic. So let me start with the today's topic. So this screen is visible. Yes, Sheetal madam, is it
Yes,
visible?
sir. Yes, sir.
Okay,
It is visible.
thank you very much. So welcome to one and all on a topic analysis of algorithm with a big O notation. So myself, Dr. S.B. Kishore, welcome you all in the today's session. So we will start with a very basic. I'm assuming here that you don't know anything about the computer. Okay, by considering that, we will start, and first of all, we will explore what is exactly algorithm, and then we will shift to the analysis of algorithm. So first 10 to 15 minutes, we will devote on what is exactly algorithm, and we will try to understand the meaning of algorithm and its usefulness while writing the programs. Let's start. Yes, addition of 2 plus 2. It should be an open to all to give the answers. Yes, please. 4. Okay.
4.
8 plus 7.
15.
15. Good. And what about next number? Now don't try to solve it. See what happened when you have given the answer of 2 plus 2. When I ask you to perform the additions of 2 plus 2, you have given the answer very quickly. It might be possible that you have not thought anything and you have given your answer. Okay. So within the fractions of second, you have given your answer. When I'm asking you to find out the additions of 8 plus 7, so you took a certain fractions of second in order to give the particular answer. And now when I'm asking you the third number, you are taking a lot of time. What is the basic reason behind this?
Because
Yes.
it needs some mind calculations. That's why it needs some time.
It takes some time. Okay. It means we can say that for a person to solve this particular problem, vary from one person to one person. It might be possible that someone may solve this particular problem within a minute and someone may take some more time. It means when you are performing such kind of calculations by a manual work, it may vary. The time factor may vary. Okay. Now, when you are going to solve the same problem using the machine, it will take the same amount of time. What is the reason? Anyone? And when I'm talking about here machine, it means I'm talking about the computer. Because reason is very simple. See, we know that what are the characteristics that has been available on computer to perform the machine level operation? It is only zeros and one. It means all these numbers are going to be converted into the form of what? Zeros and one. And we are calling them as what? A binary number system. So irrespective of this number, for example, if you are performing the additions of 2 plus 2, what is going to happen? It will convert this two number into the binary equivalent. And when you are talking about the number integer, usually I'm saying it will take a 2 bytes. It means this number 2 will be converted into the 16-bit format in a binary. Same thing is going to be happen with this number also. And that's why we say that computer will perform this any one of this addition on a same amount of time. Okay, so computational time to solve the above problem will remain what? The same, irrespective of the complexities of the number. That is what the basic advantage when you are going to solve this particular problem by means of a computer. Okay, now this is what our oral discussion. 2 plus 2 is how much, 8 plus 7 is how much. Now suppose if I want to write a certain step in order to solve this particular problem. What are the two unknown numbers? Suppose if I'm asking you, find out the additions of two numbers. What will be your first question? Yes. If I'm asking you, find out the additions of two numbers, what will be your first question? Of course, you need what? Two numbers. Okay. So unless and until you don't have a two numbers, you are not able to perform the addition. So now, how I am going to write a step for this? Let's see. It means, first of all, you need to accept the two number, right? Please keep unmute yourself, students. No issue. So it means, first of all, what you need to do, you need to accept the two numbers. Once you know the two number, what you will do, you will perform their addition and will store the result somewhere. What is our job? To find out the additions of two numbers. That is over. So simply display the result and finally stop. Now, what is A and B? We are calling them as a variable. Why variable? Because the values of A and B may vary. Someone may accept the value of A as 2 and B as 2. Someone may use it. Someone may accept the values 8 and 7. It means the values may get vary. And since the values may get vary, we are calling them as what? A variable. Okay. Now, what is C?
Variable.
So then why we are not accepting the value of C?
Because
we are
we are
storing the
using
because we are storing the value of addition in the C.
Okay, so here you need to understand about the variable. See, when I'm saying about A and B, they are calling as what? Inputting variable. I'm calling them as specifically inputting variables. Okay, then what is A plus B? What is this plus? It is an arithmetic symbol. Okay, so you may use minus, multiplication, division, etc. other operators. Then what is the meaning of this equal sign? Assign the values. Before that, what is A plus B? It is called as an expression. This entire is what? An expression. Then what is equal? It is called as an assignment operator. It means we are storing the result of this into a C. Now, what is C? C is called as a computing variable. Please remember, A and B are referred as what? Inputting variable, while C is what? Computing variable. It means we need to calculate certain, we are storing the result of certain calculation result in a C, and that's why we are calling it what? A computing variable. So from now onwards, always remember, whenever you are accepting some values, we are calling them as what? Inputting variable. And whenever you are storing a certain result, you call it as what? Computing variable. Okay. Now, here we have used a notation something like accept, display, and stop. Again, it is not necessary when writing the algorithm, you should use this kind of keywords. Someone may write here read, get, okay, or input. Instead of display, someone may write what? Put, write, print, etc. It means for a time being, I'm assuming these are what? My keyword. Okay. In algorithm, again, let me revise. In algorithm, there is no keywords. Okay, we are specifying. It means someone may use here instead of accept, someone may write input or get or some other terminologies. So in terms of notation, two algorithm might be different, but in terms of step, they will remain what? Same. Now, let us try to define algorithm. Solving a problem. Solving a problem in our own notation. See, I am using a word called own notation. So like I earlier said, instead of accept, someone may write read, get, input. Instead of display, someone may write print, put, write. Instead of stop, someone may write what? End, halt, or exit. It means it is not binding on someone to write a specific word when we are writing an algorithm. Okay, it's a free format language. Now, solving a problem in our own notation. Now, why you are solving a problem? To achieve a desired result in a certain order or sequence. It means you need to follow certain order. Now, before accepting the values, can you perform the addition?
no.
No, sir.
No. Okay, it means this is what? The steps are not in order. The steps are not in order. So, you need to follow a certain specific order in order to perform this operation. So let's take one more example. Now, is it correct? We have accepted the two values and then we are performing what? The addition. And now here I am writing stop before displaying the values. Again, is it correct?
No,
No,
sir.
sir.
No, it means the order or we are not following certain order. So let's see now. Solving a problem in our own notation to achieve a desired result. So what is the meaning of achieve a desired result? See, here we are performing this particular operation. Assume with a computer, your manual result and computer result must get matched. That is the most important part when I'm saying a desired result. Simply getting a result is not enough. Suppose if you want to find out the additions of two numbers and by mistakenly, instead of A plus B, suppose you have written A minus B, you are going to get a result? True. But is it a correct result? No.
No.
Okay. So that's why I'm saying what? A desired result. So solving a problem in our own notation to achieve a desired result in a certain order or sequence is known as what? Algorithm. Okay. Now let's try to explore some more algorithm. Now assume that we want to find out the addition, subtractions and multiplications of two numbers. Okay. So again, how many numbers are unknown? There were only two unknown numbers, so accept them. Then perform addition, then subtraction, then multiplication, and finally what? Display the result. How many inputting variables are here?
2.
2. And what about computing variables? How many computing variables? 3. It means what? It depends upon the problem that you are going to solve, that how many inputting and computing variable one may required. You cannot consider that in this particular problem I will require only 2 and in this that. Okay, so it depends upon the problem that you are going to solve, that how many inputting variables and computing variable one may require to solve that particular problem. Okay. So remember, it depends upon what? The problem to problem, how many inputting and computing variable one may require to use. And here, how many values we are displaying? 3 values. While we have accepted only 2 values, but we are displaying how many results? 3 results. Okay. So again, it depends upon what? How many values you would like to display after solving that particular problem. Depending upon that, you are going to use a display statement. Now, take one more example. Let me again remind all of you, for 10 to 15 minutes, we are simply solving an algorithm. Once you got the basic idea about the algorithm, we will shift toward the analysis of algorithm of our today's topic. Now, assume that if you want to find out the addition of two constant integer values. So here, both the values are what? Known. To find the additions of two integer constant, say 17 and 19. So assume the first value is what? 17. So simply initialize it or assign it. Similarly, the second values, and then perform the addition and display the result. Okay, it's very simple. Now, what is the new here? Here, 17 and 19 are what? They are called integer constant values. Okay. Now, x is integer, y is also integer. So z will also remain what? It will also remain the integer. It means before that, x is equal to 17. This is equal sign represent what? Assignment. Remember, we are storing the result of this into x. And x plus y is what? Same type expression, because we are assuming both of them as what? Integer constant. So value of z will also be what? It will also remain the integer only. Okay. Now, to find out the additions of three number, let's check. So how many unknown numbers are there?
3.
3.
3. So accept them, then perform the addition, display the result, and stop. Now, if you want to find out the additions of say 40 number, is it a good solution? Like accepting the 40 variable a, comma b, comma c, comma d, and so on up to? No. It means for solving a small set of data, this kind of solution can be okay. But when you are talking about a large set of data, so this kind of solution cannot be a good. Okay. So let's see. Can it be a good solution if you want to find out, say, the additions of 40 numbers? So of course not. Okay. So what you required? You require some other concepts. So for a time being, I am saying for a time being, we can solve such kind of problem by means of what? Array. Array is one of the good solution where we are able to store a large values of what? Set of data in a single variable. And then we are able to perform what? The operations on individual. That is the basic advantage of array. Of course, this is not an topic of our today's session. I am simply moving towards what? From small set of data towards the large set of data. Now, to find out the area of circle, let's see what is the unknown. Okay, before that, what is the formula? Pi r square. Okay, what is the unknown? The value of r. So accept it and assign the value pi, that is what? 3.14. Then perform the calculation, then display the result and stop. Okay. What is the new thing here? We are representing what? A pi. So whether pi is a constant or it's a variable, what it is?
Constant.
Pi is holding a constant value. Remember, pi is holding a constant value, sorry. So pi is not a character set. Again, remember that we have not represented pi over here. What we have written here? Pi. Why so? Because computer character set does not allow such kind of symbol to represent or to store certain values in such kind of symbols. Okay, that's why we use what here? Pi. So 3.14 is what? It's a floating constant value. And now finally, pi equal to r into r. It is what? Mixed type expression. Assume the value of r is integer. So pi is what? Floating. So float value into integer. Overall result will be what? Float, and hence it is referred as what? Mixed type expression. Earlier we have seen what? A same type expression, and this is what your mixed type expression. Now one more problem to find out the diameter and circumference of circle. So formula has been given over here on the left hand side. Now this is what your radius. Okay, so what is the unknown? The value of r is unknown, so accept it. Then diameter is equal to what? Twice r. Then circumference of circle is what? 2 into 3.14 into r, and finally display two values. Okay, so nothing new in this particular problem. What we have done here, instead of specifying the value pi is equal to 3.14, what we have done, we have directly put that particular value during the expression, solving the expression. Earlier, what we have done, in the earlier case, we have stored the value 3.14 in a pi, and then we have written pi. So instead of that, what you can do, you can also use such kind of constant values during the expression. Okay. Now, to find out the simple interest, what is the formula? P and R divided by 100. Okay. So unknown values are what? Three values. So accept P and R, perform the calculation, display the result, and stop. Okay. Nothing new. Now, question arises. What is a common step in all the above problems? Yes.
Accepting the
What are the
values
common
of
steps?
variable.
Input,
Yes.
calculation and display.
Speak loudly little bit, beta. In
Input,
all above problems, I'm not talking about previous problem. I'm talking about all the problem, right? From additions of two number to our simple interest. We have solved some 7 to 8 algorithms. So what is the
Yeah,
common
that
step in
is,
all the above problems?
that is accepting values and then doing calculations and then displaying that value, calculated value.
Good, 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 good. So it means, first of all, what you need to do, you need to input the unknown values. First of all, you need to accept what? The unknown values. Then perform the calculations on that particular input values, and finally you will get what? Result. So if you are going to solve such kind of problem, any mathematical problem solution, of course you will find these three steps only, major three steps. Okay. Now we are calling them as what? IPO, called as input, process, and output. It means, first of all, you need to accept certain value, then perform certain processing on that input value, then only you will get what? The output. Okay. So input, process, output is the basic process through which computer works. It involves the stages of what? Accepting, processing it, and generating the outputs. Okay. Now here output can be saved on a secondary storage media depending upon the problem that you are going to solve. So remember, IPO means what? Input, process, and output. Now we are going to talk about the process. This is the most important word. Okay. And we will discuss about the process within the next two slides only. Now, to find out the average of three number and display what? The sum and average values. Let's see. And we are also going to talk about what here? IPO cycle. Input, process, output. And now this output become what? The input for the next statement or subsequent statement. Input, process, and output. And this output become what? The input for the subsequent statement. So what is our problem? To find the average of three number and display what? The sum and average values. So first of all, unknown values are what? There were three unknown values. So accept them. Then perform the calculation and store the result in a which variable? Computing variable. Yes. Now observe here. This computing variable has become what? The input in our next statement. See, output has become what? A input in our next statement. So this output has become the input for the next statement, and hence it is called as what? IPO cycle. Okay. And finally, we are displaying both the result, that is sum and average. So remember, IPO cycle means what? Where the output of first statement may become what? Input in our next or subsequent statements. Now, what is process? In general, a process means the way in which the statement of the problems are executed. The statement of the problems are going to be executed. So on the basic of that, we have basically three types. One is called sequential process, then second one is conditional process, and the last one is iterative or looping statements or iterative process. So these are the basically three processes you follow any computer language. these are the basic steps, or these are the three basic process by which we are going to solve all the problems. So let's see once again sequential process. When a sequence of steps is executed one after another is known as what? Sequential process. It means there is a guarantee that each and every statement that you have written in that particular problem is going to be executed. For example, if you want to find out the say mean of two number, okay, so first unknown values or what? There were two unknown numbers, so accept them, perform the addition and divide it the result. Now we are not storing this result somewhere. In the same expression, after performing the addition, it will do what? It will divide that particular number in order to find out the mean. Finally display and stop. So here there is a guarantee that each and every statements are going to be executed. Okay, so that is what? Sequential process. So every statement is executed one after another. Okay, so this kind of solution to the problem gives a guarantee that execution of each statement or instruction. Now we will discuss about the conditional process. When a flow of sequence depends upon certain condition, when a flow of sequence it depends upon certain condition, then the process is known as what? Conditional process, and it is also referred as a branching statement. So let's see one example. So basically it does what? It will alter the normal flow of order of execution. We have seen in sequential process, there is a guarantee that each and every statements are going to be executed, but that is not the case when it comes to the conditional process. For example, before that, we have a relational operator which are useful to compare the two values. So these are the some of the relational operators. Sorry, these are the some of the relational operators that has been given over here, and these operators are useful to compare the values. Okay. So when compare the two values, make sure that two operands must be of same type for the getting a proper result. It means if you are comparing 15 with 5, there is no problem. It means this is the integer value. This one is also integer value. So this is a valid statement. But don't try to do something such kind of thing. Here, see, this is what integer value. This is what your string values. Okay. Collection of character is referred as what? String. So we are trying to perform such kind of comparison. So don't ever try to do. It may give some unpredictable results. So now to check number is even or odd. Okay. So how you are going to check? If the number is divisible by 2, it means that number is even, otherwise it's the odd. So first thing is what? Accept the unknown values. Then find out the remainder. So mod operator is useful to find what? The remainder after the division. For example, 12 mod 4 use what? Remainder 0. 9 mod 2, it means when you are trying to divide a 9 by 2, you will get the remainder 1. Similarly, 8 mod 3, it gives 2. And 2 mod 3, when numerator is less than the denominator, then result will be always what? It is always a numerator. Remember it. Now, number mod 2. Okay, so you will get what? One of the result, either 0 or 1. So now here you need to check what? If the remainder is 0, if it is, then number is even, otherwise it's a odd number. Okay. Now, if you want to display a hello message 5 times, we are talking about iterative process. If you want to display a hello message 5 times, this is one of the solution. First time, second time, third time, fourth time, fifth time, and then stop. Now, is it a good solution if you want to display hello 50 times?
No, sir.
Of course not. Okay. So what we need, see, this is what sequential steps. We are executing all the statement in a sequential manner. Okay. So is it a good solution? So of course not. If you want to display hello message 50 times, this is not a good solution. Then what is the solution? Solution is iterative process. So now how to write the iterative process? Let's see. We can also perform this operation using a if go to statement. Let's see. Assume initially value of I is what? 1. 1 is less than 5. Yes, condition is true. So display the hello for the first time. Okay. Then the value of I will become 2. Now go to step number 2. Now 2 is less than 5. Yes. So again print the hello for the second time. And the value of I will become 3. Go to step 3. 3 is less than 5. Yes. Again print the hello third time. Similarly fourth time. Then the fifth time. 5 is less than 5. No, it is equal. So hello for the fifth time. Then the value of I will become what? 6. Go to step number 2. 6 is less than 5. No. It means condition is false. Okay. So control will be transferred to the next statement. So in this case, it is what? Stop. Now assume by mistake, instead of go to step 2, suppose if I return here, go to step 1, what will happen? it will become an infinite. Okay, so whenever you have three things with you, initial value, conditional value, and reiterative value, in that case always go with the for loop. Now see how we are writing. I is equal to 1 to 5, and it is incrementing by what? A step value that is called 1. So initially value of I is what? 1. 1 is less than 5. Yes, hello for the first time. Then the value of I will increment by 1. Why by 1? Because step value is 1. So it will become 2. 2 is less than 5. Yes, hello for the second time. And this process will be continue up to 5. The moment value of I will become 6, condition will become what? False. So control will be transferred to the next statement. Now observe here, remember this step. It will come out when the value of I will become 6. Now assume if it is n, then when it will come back, when the control will be transferred to the next statement, it will be on nth plus 1. Remember, now instead of 1 to 5, if it is 1 to n, okay, now the control will be transferred to the next statement when the value of I become n plus 1. Okay, so remember this step. This is going to be helpful when we are going to analyze our algorithm. Now, to display the hello message 5 times, so one may write like this, 1 to 5. Is it necessary to write from 1 to 5? No. Someone may write from 10 to 50 with step value 10. Someone may write from 2 to 10, step value 2. So it is because our problem is what? Simply display hello message 5 times. So anyone can use any kind of loop. Now this is called as what? Forward loop. Okay, starting to ending. Someone may use also backward loop, like 5 to 1, step minus what? 1, in order to print the hello message. Okay. Now, irrespective of times, how many times you may execute this particular algorithm, it will always print what? Up to 5 times only, because it is what? Static approach. So we will see about the dynamic approach. Now we have a basic knowledge about the process. Okay, that is what? Sequential process, then conditional process, and iterative process. We know what is exactly algorithm. Okay, and now it's time to start with the analysis of algorithm. If you remember, I said that if you want to find out the additions of three numbers, what we have done, we have written accept ABC, and then we have performed the addition. And at that moment, I asked you, is it a good solution to find out, say, additions of 40 numbers? So what was your answer? No. Okay, it means what you need to understand here, it refers to the determinations of computing time and storage space requirement of an algorithm. Analysis of algorithm refers as what? It refers to the determination of computing time and storage space. It means it is the study of time versus space, that how much time is going to require to solve that particular problem, and at the same time how much space it will occupy for solving that particular problem. Okay, so when I'm space, I'm talking about here variable only. Okay, please remember, I'm not talking about the instruction, I'm talking about the variables. Okay, so when I'm talking about the storage space, remember again, I'm simply talking about the number of variables that may required in order to solve that particular problem. Because the more variable, it means there is a more transmission between what your memory to ALU. ALU does what? It will perform the arithmetic and logical operation, while memory does what? It will store the values. So each time you are incrementing the values by 1, or whenever you are performing certain operations on the variable, there is a much more transmission between what? The variables and the memories. The memory locations and your ALU. Now, the phrase analysis of algorithm was coined by Dr. D.E. Knuth, and he is also referred as the father of your database. Now, factors considered while analyzing the algorithm. Just as told you, we are talking about the what? Space, the number of n is what here? Number of input values that you are going to insert, and time. Okay, so we have a certain problem. Okay, you need to find out what? A best solution with respect to the time and with respect to the space. This is our major part, the topic of our today's discussion. We have a certain problem. You need to solve that particular problem by means of what? Certain algorithm, by selecting what? With respect to best time and with respect to the best storage space. And then only you are going to implement this algorithm using any one of the language. Depending upon the features of that particular language, you are going to solve that particular problem. So, the complexity of an algorithm is determined by what? The combinations of space and time respectively. What do you mean by space complexity? The space complexity is the amount of memory needed to perform given a task. It is computed by considering what? A data type and its size. Okay. So I hope that you are, see, I have used two words, integer and floating. So basically, when we are talking about some integer value, it takes 2 bytes. Okay. So for a timing, simply remember, if you don't know about the computer, nothing to worry. Okay. So whenever we are storing certain values, integer values, so we need what? Integer variable. And whenever you are going to store, say, floating values, we need a floating variable. So when we are performing this operation using computer, we need what? Certain storage space, storage type. So in that case, we are going to use what? Integer and float, nothing else. Now, the size of data type is dependent on the particular language and hardware and operating system. For example, when you are talking about integer in C, it takes only 2 bytes, while in Java, it requires what? 4 bytes. Of course, the range is also different when we are talking about 2 and 4. In C, under this DOS, it requires what? Less than 2 bytes in order to store the integer values, while in case of Unix, it may require what? Less than or minimum 2 bytes. Now, to find the largest amount of 2 unique number. And now with this particular problem, we are starting the analyzing of each and every algorithm with respect to space and time. So first step is what? Accept the two values. Now, if the value of A is greater than B, then display first number is large. Otherwise, second number is large. It means one of the statement is going to be execute, not the both. Okay, it's very simple. Okay, now assume if you want to find out the largest among the 6 number. Largest among the 6 number. So there are basically okay, after comparing, one result will be true. That is either first number is large or otherwise second number is large. Okay, we have seen already it. Now, to find the largest among the 6 number, and we are giving a 3 solutions in order to solve this particular problem. Okay, so let's discuss all of them one by one. Method 1. So accept what? How many variables? 6 variables. And assume for a timing, the values of A, B, C, D, E, F are what? 95, 85, 75, 65, 55. See, all of them are what? In descending order, except the last one. Except the last one, all of them are in the descending order only. Now compare. How you are going to write? If A is greater than B, A is greater than C, A is greater than D, A is greater than E, and A is greater than F, then what? Largest is what? F. So after how many comparison? By 5 comparison, you got a largest number. Now, in our case, this condition is what? False. Last condition is false. It means it will jump to the else part. Again, we are checking what? Whether value of B is greater than with other. If it is so, B is large, otherwise else part. So the value B is large. After how many comparison you will get this particular result? 9, almost. We are talking about in worst case. Similarly, about the C, after 12 comparison, similarly D, after 14 comparison, and the last one, E is greater than F or not. So after 15 comparison, you will come to know that your which number is large? The last number was the largest number. After 15 comparison, you come to know that your largest value is what? The value that you have stored in a variable F. So this is what your worst condition. Now, what is the best condition? When the first number itself is a large. That is what? A best. And in between them, it's what? You may call? Before that. Okay, let's see here. Here we require a maximum 15 comparison to know the largest number. Now here, thus in worst case scenario, this method required how many variables? How many computational time? N into n minus 1 divided by 2. N into n minus 1 divided by 2. See, what is the value of n? How many values are there? 6 numbers. So 6 into 6 minus 1, that is 5. So overall result is what? It's a 15. So in worst case, how many comparison will be required? For 6 variable, it's the 15 comparison. See, ये थोड़ा ध्यान में रखना, n into n minus 1 divided by 2. for if there were n variables. If there were n variables, in that case, you will require this many comparison in worst case. Okay. And what about the storage space? How many variables you will require? 1, 2, 3, 4, 5, 6, and large is one more variable. So S of 6 is what? 7. It means in general, if there were n variables, you required how many total variable is what? N plus 1. This part is clear?
Yes, sir.
Yes, sir.
Good. Now, discuss about the second method. Initially itself, now we know very well iterative statement. So initially assume the value of large is 0. Now for I is equal to 1 to 6, accept a number. Now if the number is greater than the value that you accepted, the new large will be what? Your current number. And this process will be continue. So after how many comparison you will require here? Any guess? See, initially value of large is 0. I is equal to 1 to 6. Accept a number. If number is greater than large, so assume the first number is 5. 5 is greater than 0. Yes. So your new large is what? 5. Again, go back to the loop. Accept a new number. Assume it's a 10. 10 is greater than 5. Yes. So your new large is what? 10. And this process will be continue. So how many comparison do you think it's required?
Up to large number is founded.
5 or 6 or how many?
Up to large number is found.
Up to large number is found. See, this loop is going to be execute only 6 times, na beta? This loop will execute only 6 times.
6 comparisons.
See, total in all we required. Now these statements are going to be executed 6 times. That is true. All these 3 statements are going to be executed.
Yes, sir.
All these two statements are going to be executed at least 6 times. That is true. ये दोनों स्टेटमेंट 6 बार एग्जीक्यूट होंगे, ये तो क्लियर है?
Yes, sir.
Yes. Now observe what I told you in the previous case. ये लूप कब खत्म होगा? जब IQ वैल्यू 7 होंगी तब बाहर आएगा. इसका मतलब यहाँ पे कितने कंपैरिजन हो रहे हैं? 7 टाइम्स कंपैरिजन हो रहे हैं. और यहाँ पे कितने बार कंपेयर हो रहे हैं? 6 बार कंपेयर हो रहे हैं. टोटल कंपैरिजन. यहाँ पे ये लूप कब टर्मिनेट हो रहा है? When the value of I will become 7, then only control will be transferred to the next statement. Remember, so it means here we are going to comparison. How many comparison? Almost 7 comparison, and here it's a 6 comparison. So overall 7 plus 6 is what? 13 comparison. So let's discuss. So here we require total 13 comparison. 7 to terminate the loop. That is 1 is less than 6. Yes. So on up to 6 is less than 6. True. 7 is less than 6. False. So it means total 7 comparison. And each time it executes the body of the loop, it will check whether the number is large or not. So it means these steps are going to be executed 6 times. Okay. ये कंपैरिजन भी 6 बार हो रहा है. तो ओवरऑल हो गया हमारा 13 कंपैरिजन. तो अब n अगर वेरिएबल होंगे इंस्टेड ऑफ 6, अगर n होगा तो कैसे आएगा? 2 into n plus 1. ठीक, n की वैल्यू अब यहाँ पे कितनी है? 6. तो 2 into 6 that is 12. 12 plus 1 13 कंपैरिजन. ओके. एंड नंबर ऑफ वेरिएबल कितने लग रहे हैं हमको? वी रिक्वायर्ड ओनली 2. दैट इज व्हाट? लार्ज एंड नंबर. वी रिक्वायर्ड ओनली 2 वेरिएबल. But what is the drawback of this method? The moment you accept the second number, you are going to lose your first number, the earlier number. That is the drawback of this method. Okay, we will discuss about all these things during the comparison chart of all the 3 methods. यहाँ पे क्या हो रहा है? हमारी ओरिजिनल वैल्यू क्या हो रही है? लॉस हो रही है. फर्स्ट, like I said, accept the first number. Assume it's a 5. The next time the value of accept number is what? 10. It means what? What is going to be happen? The new value will be overwrite on a variable number. It means you are going to lose your previous values. That is the drawback of this method. And for n variable, storage spaces will remain what? 2 only. देखो, पहले केस में हमारा स्टोरेज स्पेस कितना था? 7 था, मतलब n plus 1 था. ओके. इन दिस केस इट इज ओनली 2 ओनली. अब यहाँ पे 6 नंबर रहे या 2 नंबर रहे या 10 नंबर रहे या 1000 नंबर रहे, it will require only 2 variables only. Finally display the large and stop. Now the third approach. However, in this method, one is not able to access the previous data if needed later on. That is the drawback of this approach we have just discussed. Now the third method, to find the largest among the 6 numbers. Now here we are going to use the 2 variable. That is the drawback of this approach. We have just discussed. Now the third method, to find the largest among the 6 numbers. Now here we are going to use the 2 variable. That is the drawback of this approach. We have just discussed. Now the third method, number. Again, accept the 6 number at once. Initially assume the large number itself is a A. यहाँ पे assume करो कि पहला ही number आपका large है. It may be true or it may not be true, but assume at the beginning. Then compare whether the B is greater than large. If yes, then the B is your new large. Okay. Now compare C with your new large. If C is greater than large, then your new large is what? C, and this process will be continue. So now how many comparisons are there? Take it. कितने कंपैरिजन है यहाँ पे?
5.
5 कंपैरिजन. वेरिएबल्स कितने हैं? 6. कंपैरिजन कितने लग रहे हैं? 5. तो इसका मतलब अगर वेरिएबल अगर n होंगे तो कंपैरिजन कितने लगेंगे?
n-1.
n-1. स्टोरेज स्पेस कितना रहेगा? 6 plus 1, that is 7. Okay, so let's see. Here one required only 5 comparison to find the largest number in the list, and for n number we required n-1 comparison and 7 variable. For s of 6 is equal to कितना रहेगा? 6. तो for n के लिए कितने रहेगा? n plus 1 रहेगा. And now discuss all of these 3 methods by using a chart. हमारा कंपैरिजन टाइम कॉम्प्लेक्सिटी के बारे में हम बात करें. पहला मेथड में हमको इतना लग रहा था, n into n-1 divided by 2. In second 2 into n plus 1, and in third n-1. For a small value, see जब n की वैल्यू 6 है तो हमको कंपैरिजन कितने लग रहा है? 15, 13, 5. Okay, but when the value of n become 100 and when the value of n become 10,000, see how many comparison you required in first method and how many comparison you required in your last method. So now, which one is better?
Last one.
With respect to time complexity?
Last one.
When the value of, yes, please.
Last one is better.
Last one is better. तो इसका मतलब क्या है? When the value of L will increase, when you have a large set of data, number of comparison will also get increased. When you are solving in a small set of data, जब हम कभी कभी हम सोचते भी नहीं कि number of complexities क्या आ रही है, because we are always working on a small set of data. But in real life, we may come across with such a large set of data, and we need to write the solution for a large set of data rather than thinking about the small set of data. Okay, now with respect to space, let us discuss. स्पेस में कितना लग रहा है यहाँ पे? n+1. सेकंड मेथड में कितना लग रहा है? ओनली 2 लग रहा है. और थर्ड केस में भी कितना लग रहा है? n+1. मतलब n की वैल्यू अगर 6 होंगी तो 7 to 7, n की वैल्यू अगर 100 होंगी तो this, and now for n की वैल्यू अगर 10,000 होंगी तो इतना स्पेसेस हमको फर्स्ट और लास्ट मेथड में लग रहा है, जबकि सेकंड मेथड में कितना लग रहा है? ओनली 2 ही लग रहा है. तो नाउ व्हिच वन इज बेटर?
Second one.
Second one is better. It means now you need to decide. Now here you need to decide whether you want to go for the time or whether you want to preserve the space. What is the important for you? Okay,
Space.
and that is what the analysis of algorithm is. वही है हमारा एनालिसिस ऑफ एल्गोरिथम, कि हमको क्या चाहिए, मतलब हमको स्पेस, मतलब स्पीड चाहिए कि हमको स्पेस बचाना है. तो ये दोनों का कॉम्प्लेक्सिटी, हमको ऐसा मेथड चाहिए कि दोनों भी हमारा बैलेंस हो. नो डाउट इट इज वेरी डिफिकल्ट. Okay, but we need to find such kind of solution. Again, remember, these are the not only 3 solutions in order to solve that problem. It might be possible that someone may come with some new solution for solving the same problem with lesser number of comparison and with less storage space. Okay, so here we have solved a same example using the 3 different approach, and we are discussing about the complexities of all these 3 algorithms. Is it clear?
Yes, sir.
Yes.
Okay, now when we compare the efficiency of different types of algorithm, there 3 cases can be considered. What are those? Best case, worst case and average case. तो मतलब आपको ये 3 में से कोई तो भी एक आपका रहेगा कि बहुत ही बेहतरीन सॉल्यूशन मिला है आपको विथ रेस्पेक्ट टू टाइम एंड स्पेस, या फिर बहुत ही मतलब नॉट दैट मच ऑफ गुड एंड एवरेज इन बिटवीन दैट. Okay, so you need to take one of these while solving a particular problem. So as we can see, different algorithms have what? A different time and space complexity. One should follow the appropriate method at the appropriate place by considering what? The time and space trade-off during the design of an algorithm. So you should always think what is the important for you, for your organization, whether it's a space or speed. Okay, so based on that, you should follow the algorithm. So in general, when one tries to reduce the space, it will take more time to access or extract the data and vice versa. मतलब अगर हम एक बचाने की कोशिश करेंगे तो दूसरा ज्यादा लगेगा, अगर टाइम को कम करने की कोशिश करेंगे तो स्पेस बढ़ेगा, स्पेस को कम करने की कोशिश करेंगे तो टाइम बढ़ेगा. ओके, सो दैट इज ऑलवेज देयर. नाउ व्हाट इज बिग ओ नोटेशन and how it is useful? Big O notation is a technique to determine the complexities of the different methods of solving a same problem. Okay, without reference to any particular machines or compiler. Please remember, when we are talking about a big O notation, we are not thinking about any particular machine, neither we are talking about any compiler or operating system or anything. We are simply talking about the algorithm. Comparison in terms of what? About what? About the algorithm. So here, O stands for what? The order of function. In case of, when you are talking about big O का मतलब क्या है यहाँ पे? Order of function. It is also called as what? Asymptotic notation. We will discuss about this order of function within a moment. So as algorithms are independent of machine, please remember we are not able to execute any kind of algorithm on any computer programming language. We are implementing the algorithm by means of certain languages, but as such, we are not able to execute the algorithm. Okay, using language, what we are doing, we are simply implementing the concept of algorithm. So as algorithms are independent of machine, the technique will calculate the complexity depending upon the number of elements and method that has been used in order to solve that particular problem. Now, this is another chart for you. Order of execution. If a particular statement is executed only one time, then we can say it is running only on constant time. Okay, for example, when you are performing the additions of two numbers, something like that, for performing any basic arithmetic operator, it is always what? Time is what? Always constant time. When magnitude is what? O, big O notation log n, it is considered somewhat superb, and it is what? Name is what? It is referred as a logarithmic, and it is useful to find the atom in a sorted array using a binary search. Okay, so based on this, now please remember, based on this, there were, depending upon the problem, you may have a different types of magnitude or order of function. For example, O factorial, big O notation, n factorial. It is considered as one of the worst situation, and this kind of problem can be used while traveling a salesman problem using a brute force method. जब आप इस मेथड से इस प्रॉब्लम को सॉल्व when you are trying to solve this traveling salesman problem, okay, using a brute force method, in that case you may require such a timing. Now big O notation को हमने यहाँ पे देखे, इसका नंबर में देखते हैं. Suppose the value of n is 1. In that case log 2n कितना ले रहा है? Constant time ले रहा है. And see, up to this ज्यादा फर्क नहीं लग रहा है. जब small set of data होगा तो ज्यादा फर्क महसूस नहीं हो रहा है. But when the value of n is increasing, what is n? The number of your input values or your data. When the value of n is say 32, log n में कितना लग रहा है? Only 5 steps. In this case this, in this case, and see what about this? Almost 429 lakh 49,006 429 crore 49 lakh 67,296. इतना हमको क्या लग रहा है? Complexity उसकी रहेगी. When the value of n is 32 and if you are going to solve using a traveling salesman problem, see. Okay, so now we will try to understand कि ये find out कैसे करते हैं. Now for a function f of n, suppose एक function दिया है n cube plus n square plus 5n plus 5. So find the order of magnitude. Now what is the most determinant over here? सबसे ज्यादा important factor कौन सा है यहाँ पे?
n cube.
It's the n cube. Okay, so here for the larger value of n, n cube will be the dominant function and hence we can ignore the other terms. क्योंकि ये dominant रहने की वजह से हम क्या कर सकते हैं? इसको ignore कर सकते हैं. The order of function is what? Big O notation n cube, cubic time. It is called as a cubic time. Okay, so now let's try to understand. Assume the value of n is 10. So 10 to the power 3 is 1000, 10 to the power 2 100, and this. Finally, ये जो नई वैल्यू आ रही है वो कितनी आ रही है? 1155, which is nearly equal to 1000. It means we can ignore this value. जब हम लार्ज वैल्यूज के लिए जाते हैं तो ये टर्म को हम क्या कर सकते हैं, इग्नोर कर सकते हैं. सी ऑब्जर्व दिस वैल्यू. Okay, so we can say that the magnitude of the function is what? Big O notation n cube. Okay, now find the frequency count and magnitude of the time complexity of the following algorithm. Assume करो ये तीन स्टेटमेंट आपको दिए हैं, डिस्प्ले हेलो, डिस्प्ले हेलो, डिस्प्ले हेलो. कितने बार एग्जीक्यूट होगा तीनों भी?
One time each.
हर एक स्टेटमेंट कितने बार एग्जीक्यूट हो रहा है यहाँ पे? ओनली वंस.
One time.
ओके, तो इसका मतलब हम क्या बोल सकते हैं, इस स्टेटमेंट विल बी एग्जीक्यूटेड ओनली वंस. तो टोटल फ्रीक्वेंसी काउंट कितना है? 1 + 1 + 1 दैट इज 3. सो मैग्नीट्यूड ऑफ टाइम कॉम्प्लेक्सिटी कितना रहेगा? बिग ओ नोटेशन 3. तो 3 इज व्हाट? इट इज अ कांस्टेंट वैल्यू. सो वी कैन से दैट दिस एल्गोरिथम इज गोइंग टू बी एग्जीक्यूट ऑन अ कांस्टेंट टाइम. ओके, नाउ टेक अनदर एग्जांपल. सपोज दिस इज एन एग्जांपल. यस इज इक्वल टू 0. ये स्टेटमेंट कितने बार एग्जीक्यूट होगा?
One
One
time.
time.
ओनली वंस, राइट? व्हाट अबाउट दिस? ये स्टेटमेंट कितने बार एग्जीक्यूट हो रहा है?
N times.
n + 1. एंड व्हाट अबाउट दिस?
n+1.
n टाइम्स होगा. ठीक है, तो yes is equal to 0 will be executed only once, while second statement will be executed n + 1 time, while the third will be executed n + n time. तो overall timing क्या हो गया? 1 + n1 + n, that is twice n + 2. Okay, so again what is the most determinant factor? यहाँ पे कौन सा रहेगा? The value of n is the most determinant या dominant factor बोल सकते हैं हम इसको. Okay, so the order of magnitude will be what? Big O notation n, that is what? It is executing on a certain linear time. It is executing on a certain linear time. Now take this example. This statement will be executed only once first. What about the second?
N + 1.
N + 1. What about this?
N square + 1.
Okay. Now अब ये मुझे बताओ, ये स्टेटमेंट कितने बार एग्जीक्यूट होगा? n + 1 की कितने बार?
N +
यस
1.
यस यस यस. ये स्टेटमेंट कितने बार होगा अभी एग्जीक्यूट?
N + 1.
See, it is n square and this is what your n. It means टोटल क्या हो गया हमारा? n क्यूब हो गया. प्लीज रिमेंबर, देखो ये क्या है? 1 to n है. ये कितने बार एग्जीक्यूट हो रहा है? n स्क्वायर टाइम्स. इन जनरल हम फिलहाल +1 छोड़ देते हैं बिकॉज दैट इज नॉट ए डोमिनेंट फैक्टर. ओके, तो हम फिलहाल ये बोल सकते हैं कि इट इज n स्क्वायर टाइम्स. और n स्क्वायर टाइम्स कितने बार एग्जीक्यूट हो रहा है? ये n टाइम्स हो रहा है. तो इसका मतलब क्या हो गया? टोटल n क्यूब टाइम्स. इज इट क्लियर?
Yes, sir.
फॉर ए टाइम बीइंग सिंपली इग्नोर दैट 1. फिलहाल इस प्रॉब्लम हम सोच नहीं रहे बिकॉज वी नो दैट 1 इज नॉट वन इज सिंपली a constant time. So you can ignore that one for a time being. Okay, so let's see overall. The statement s of 0 will be executed only once. S is equal to s + 1. This will be executed how many times? ये स्टेटमेंट कितने बार एग्जीक्यूट हो रहा है?
n³ time.
n क्यूब टाइम्स एग्जीक्यूट हो रहा है. दिस पार्ट इज क्लियर?
Yes, sir.
हेलो. So what is the dominant factor now?
N cube.
n क्यूब. So order of magnitude क्या रहेगा? बिग ओ नोटेशन n क्यूब. इसका मतलब ये कितने टाइम में एग्जीक्यूट हो रहा है? क्यूबिक टाइम में एग्जीक्यूट हो रहा है. तो जनरली हमारा जो मैट्रिक्स के प्रॉब्लम सॉल्व करते हैं, मल्टीप्लिकेशन ऑफ मैट्रिक्स, इट इज जनरली ऑन क्यूबिक टाइम्स ओनली. और एडिशन ऑफ मैट्रिक्स जो जनरली हम जो करते हैं वो कौन से टाइम में रहता है? स्क्वायर टाइम में रहता है. ओके, so for a certain problem, now last problem. For a certain problem, mastermind Akhil and Anand wrote a solution in a frequency n cube plus 25 and twice n square plus twice 200 respectively. मतलब अखिल ने एक सॉल्यूशन दिया, उसका फ्रीक्वेंसी टाइम क्या है? ये है. और आनंद ने सॉल्यूशन जो दिया उसका फ्रीक्वेंसी टाइम ये है. तो हमको ये बताना है कि दोनों में से सॉल्यूशन किसका बेहतर है. इन जनरल क्या बोल रहे हैं अभी आप? कौन सा बेहतर रहेगा?
2n square + 200.
200. That's good. Now let's see. And what are the big O requirement of each algorithm? And check both the solution for the value of n in the range 3 to 10. 3 to 10 के रेंज में हमको चेक करना है कि दोनों का सॉल्यूशन कौन सा बेहतर है. And then conclude whether the Anand algorithm is more efficient than Akhil or not by big O standard. Now let's check. For Akhil solution, big O requirement is what? It's a straightforward. दिख ही रहा हमको, क्यूबिक टाइम है. एंड फॉर आनंद सॉल्यूशन रिक्वायरमेंट क्या है? n स्क्वायर. नाउ लेट्स चेक ग्राफिकल फॉर्मेट में। n की वैल्यू 1 है तो अखिल का सॉल्यूशन क्या बोल रहा है 26 टाइम, जबकि आनंद का सॉल्यूशन देखो कितना लग रहा है 202 लग रहा है। n की वैल्यू जब 2 होती है तो 33, आनंद का सॉल्यूशन 208। n की वैल्यू जब 3 है तो अखिल का सॉल्यूशन बेहतर है देन आनंद। देन n की वैल्यू 4, अगेन अखिल solution is better than 3. When the value of n is 5, again the solution of Akhil is better than Anand. Now, when the value of S6 is, again the Akhil solution is quite better than Anand. Now, what is happening here? Last में जब जा रहे हैं तो
Akhil is getting worse.
Akhil solution is giving a better up to which case? Up to which case? All cases or hello? Up to
Up to
10
6.
तक। लेकिन हाँ आनंद का सॉल्यूशन देखो कहां से बेहतर हो रहा है फ्रॉम 8 ऑनवर्ड। 8, 9, 10 में देखो आनंद का सॉल्यूशन ओनली 400 लग रहा है, जबकि अखिल के सॉल्यूशन में 1025 लग रहा है। So when you have a small set of data, it is very difficult to find out which solution is better. Remember, that is what I want to conclude over here. When you are working with a small set of data, it is very difficult to say which algorithm is better. But when you are going for a large set of data, in that case only this big O notation concept is useful. This part is clear?
Yes, sir.
Okay. So it means we can conclude that for a large set of data, Anand solution is quite better, right?
Yes, sir.
Yes, sir.
So this is a diagrammatic form. देखो अखिल का सॉल्यूशन कैसे जा रहा है, इट इज मूविंग टुवर्ड द एक्सपोनेंशियल फॉर्मेट में, जबकि आनंद का सॉल्यूशन क्या जा रहा है कॉन्स्टेंटली मूव हो रहा है। ओके
Yes, sir.
फॉर लार्ज सेट ऑफ वैल्यूज अखिल सॉल्यूशन इज नॉट गुड बट आनंद सॉल्यूशन इज वेरी गुड फॉर ए लार्ज सेट ऑफ डेटा। अप टू स्मॉल जब रह रहा है तो देखो स्मॉल जब रहता है डेटा तो अखिल का सॉल्यूशन बेहतर है अप टू दिस, बट आफ्टरवर्ड इट इज नॉट गुड सॉल्यूशन। ओके now take one more example to find out the sum of first n natural number. It's very simple. Unknown value is what n. Initially assume the value of sum is 0, and for I is equal to 1 to n, what you are going to do, previous sum plus current value of I, and this process will be continue and you are going to get what, a result. Now क्या रहेगा इसका frequency of time, n है वैल्यू, लास्ट वैल्यू क्या है n है, तो इसका मतलब फ्रीक्वेंसी टाइम क्या रहेगा इसका
And
ये नहीं रहेगा, मतलब it is going to work on a linear time. Now question arise, is it possible to solve the same problem using another approach? See, this is our method 1. So of course yes, let's see the another solution. तो एक्सप्लेन करके बताया गया है यहाँ पे। इनिशियली सम की वैल्यू कितनी है 0, आई की वैल्यू कितनी है 1, 1 इज लेस देन 5, कंडीशन इज ट्रू, तो सम इज इक्वल टू सम प्लस आई, दैट इज 0 प्लस 1 इज 1, एंड दिस प्रोसेस विल बी कंटिन्यू। ओके दैन वैल्यू ऑफ 6 जो 6 हो जाएंगी तो लूप के बाहर आएगा, क्यों, क्योंकि हम अज्यूम करें n की वैल्यू 5 है करके। ओके नाउ द सेम प्रॉब्लम कैन बी सॉल्व बाय अनदर अप्रोच। नाउ सी दिस इज टेकिंग अ linear time in order to solve this particular given problem. Now we are giving another solution which is going to solve this particular same problem but on a constant time. Let's see. So execution time will take place what, on a linear time, big O notation n. Now the same problem, accept the value of n and now directly put them into the formula. That is what is the formula to find out the sum of first n natural number. What is that? N into n plus 1 divided by 2. What is the timing now? Constant time, right? It is working on a constant time. Is this part clear?
Yes, sir.
देखो n की वैल्यू सपोज 5 है तो 5 इंटू 6 प्लस 1, 5 प्लस 1 कितना हो गया 6, 6 डिवाइडेड बाय 2 मतलब 3, तो 5 इंटू 3 दैट इज 15, सम कितना आया हमारा 15 आया। Okay, so it means what you need to do is that in order to solve a given problem you may have more than one solution. Okay, so try to find out those solutions which will be good with respect to the time and which is good with respect to space also. Okay, and that is what an entire study about the analysis of algorithm. And this analysis of algorithm can be calculated on the basis of what? Big O notation. That is frequency of time, order of function. Okay. So last two slides, space complexity. In general, it is difficult to calculate the total space used by the program due to the following reason. See, program it's a difficult, not in terms of algorithm, because how much space compiled version of a program needs is dependent on what the instruction space and optimization technique that has been followed by that particular compiler. Okay, we are talking about what? A data space, the amount of memory needed to store the data. We are simply concentrating on this. Okay, and again, environmental space may be occupied by operating system when we are talking about a certain program, but all those cases are not required when you are analyzing the algorithm. Okay, similarly, time complexity is again difficult to find out exactly, because a time required for each machine instruction has to be determined, which is very difficult. Time required for generating the executable code has to be determined. कितना time ले रहा है वो execute code बनाने के लिए. Then what are the underlying hardware? Then type of the operating system, whether it is a Linux, Windows, and all those things. Okay, so we are talking about what here? The number of comparison. Okay, in general, it is very difficult to find out the complexity of the program, because there were a lot of other factors that you need to find out. But here we are simply concentrating on what? About the algorithm. Okay. So these are some of the references that you may follow. So thank you one and all. Now, if you have any doubts, you can ask.
Thank you, sir.
Yes.
Thank you very much for a very nice
Koi
presentation.
question?
Students, yes,
Any questions?
students, if you have any questions, you can ask sir. You can ask to sir. And the students who are on YouTube, they can drop their questions in the chat box also.
Yes, any questions?
Sir, I think the session was excellent, and with lot of examples, there might not be any questions to the students.
Thank you. Thank you very much.
Yes, sir.
Hema
It's
madam
very good presentation. And if somebody doesn't know about the computer also, they can understand the analysis of algorithm from your presentation. It's very good presentation, sir.
Thank you, madam. Thank you very much.
So, rarest of all the human qualities, consistency. And the consistency is the main quality of Dr. S.B. Kishore sir, because he is consistently doing well in all the things whichever he take overs. So we are also having with us, we feel honored to have with us the honorable moderator for today's webinar. She is a professor in the Department of Computer Science and Engineering at Aura Scientific, Technological and Research Academy, Hyderabad. She received a PhD degree in Computer Science and Engineering degree from Anna University, Chennai. Her research area are healthcare analytics, machine learning and data science. She received Young Scientist Award from Vision Group of Science and Technology, Karnataka in the academic year 2016-17. She has published around 40 research papers in national and international journals and conferences respectively. She has permanent membership in ISTE and ACCS. So here I am presenting Dr. Hema ma'am as a moderator for today's session. Over to Hema ma'am.
Okay, thank you. Thank you for your wonderful introduction, madam. Today's session was very, very good, and I think it will be useful for the students. And I request sir to take another two methods, omega method and theta method. It will be useful for students. That's all for that is my observation. Because in student point of view, analysis of algorithm is very difficult for them to understand. If we give more examples like this, they will understand in better way. Thank you.
Thank you, madam.
Thank you, madam. Thank you very much.
Welcome,
Moving,
madam.
moving towards the end of the webinar, uh, any event cannot be completed without thanking the efforts of certain people. So I would like to ask Assistant Professor Nishant Shastrakar sir to propose a vote of thanks. Over to Nishant Shastrakar sir.
Sir, unmute.
Thank you, madam. Just good afternoon, one and all present in this webinar. Just webinar on analysis of algorithm and big O notation is completed successfully. On behalf of whole organizing committee, it's my proud privilege to express vote of thanks. So, I Assistant Professor Nishan Shastrakar present here to do the same. First, I would like to express my sincere thanks to the resource person for today's webinar, Dr. S.B. Kishore sir, Chairman, Board of Computer Science, Gondwan University, Gadchiroli, Head of Department, Computer Science Department, Coordinator, Department of Computer Studies and Research, SPP College, Chandrapur, who gave this truthful webinar on analysis of algorithm and big O notation. In this webinar, he explained algorithm, not only algorithm, complexity of algorithm, analysis of algorithm, and again, he focused on big O notation also. I think this webinar is not only useful for students of computer science, but it is also useful for all the faculties, for me also, to understand this topic very well. Thank you very much, sir. Once again, thank you, sir. I would like to thank Dr. Hema Madam, uh, moderator for today's program, Dr. Hema Madam. She is from Professor in Department of Computer Science and Engineering at Aurora Scientific Technological Research Academy, Hyderabad, who gave her expert views on today's webinar and again for giving a suggestion in this webinar. Thank you, madam.
Thank you, sir.
I like to thank the technology expert, Dr. Ajay Kushwaha sir, for his kind support to arrange this webinar. Thank you, Ajay sir. I like to thank my colleague, Assistant Professor Shital Bora Madam, for proceeding this program successfully. I like to thank Assistant Professor Praveen Thakre, all my dear colleagues, and all the respected faculties from various colleges. And special thanks to my dear students and all the students from various colleges who attended this webinar to grasp this knowledge. Thank you one and all once again. And now, over to Shital Bora.
Thank you, sir. Thank you very much. With the permission of organizing committee, I would like to declare that the webinar has been ended. Thank you very much. Have a good day.
Thank you, madam.
Thank you. Thank you. Thank you, madam.
Thank you, sir. Thank you.
Thank you, all dear students.
Thank
Yes,
you,
Ajay sir. Ajay sir. Okay. So thank you one and all. Now we are leaving.